Okay, so the next topic is on how to evaluate the postfix expression. When I say evaluate, which means how the machine will actually go on with the calculation or the evaluation of the expression for a concrete result. So, having clearly understood how to convert the infix to postfix, it's now time to know how to evaluate or how to learn the technique or the method of evaluating the postfix expression. Alright? So again, just as was the case with the conversion of infix to postfix, there were certain rules. So likewise, in evaluating the postfix expressions, as you can see, there are 3 examples. There are rules, and the rules are pretty simple. There could be 2 ways, one through the diagrammatic means, and then again the second way is taking the help of the table. So based on the nature of questions posed to the examination, you'll have to either go for the diagrammatic means or the tabular format. Okay, so the rules are simple. You need to imagine a stack, and then if the symbol or the elements are operant, you have to push it onto the stack. For example, let's say A, and then you have the B, and then let's say the third symbol or the third element is the operator. You need to look out for the kind of operator. Is it a unary operator or a binary operator? Or it could even be a ternary operator. So unary operator means it just needs one operand to be operated. If it's binary operator, it needs 2 operands, right? So based on the nature of the operator, if it's a binary operator, 2 operands that have been pushed onto the stack will have to be popped off, and the result, which means the A and B will be the first one to be popped, followed by A, and then A plus B will be evaluated, the result of which will again be pushed onto the stack. So this will go so on and so forth. We'll take the help of 3 examples. We'll first do this, and then we'll wrap it off, and then we'll get on with question number 1. It's very simple. Now let's say the values of A, is 2, B is 3, C is 4, and D is 5. Okay, so this is very much an example of postfix. We have to imagine how machine evaluates this. So I'm just showing you how the machine evaluates this particular postfix expression, right? So first things first, the step number 1 will be something like this. Number 1 step is, you have the diagram of the stack. A is the first one that gets on into the stack. Okay, so since A is the operand, A has to be pushed onto the stack, and then you have this arrow, which is the representation of the top variable. Remember, the top variable keeps track of the topmost element. Okay, so as of now, since I am using the diagrams, you may not be able to weigh the importance of this top variable or this arrow. But when you actually implement the whole thing using the program, it's through the top variable, that you will be able to pop off the topmost elements, and it is through the top variable via which you will know whether the stack is in underflow situation or overflow situation, right? So in order to just denote the top variable, I'll be using the arrow sign, and then see, we are done with this. And then next up is number 2 will be, okay, I have A here, and then you have B. Since B is operand, it gets pushed onto the stack, and then you have the top variable, pointing to the B. And then you have the number 3 will be, you have the plus operator. If it's a plus operator, what happens is, since it's a binary operator, B will be popped, and then A will also be popped. Since it's a binary operator, it needs two operands. As a result of which, what happens is B will be the first one to be popped, okay, and then A will be the next. And the value of A is 2, as given the value of B is 3. 2 plus 3 is equal to 5. So the result of 5 will be pushed back to the stack. Okay, so this is how you have the 5 pushed onto the stack. In between step number 2 and 3, there will be two pop operations. There will be 2 pops, one for A and one for the B. So this 5 will be pushed. And then, now the next step is step number 4. Step number 4, you have 5 here already, and then you have 6. 6 is operand, so again C gets pushed onto the stack. Initially you will have top here, and then now this time you will have the arrow pointing to the C. Step number 5, it's very simple, right? You have 5 and then you have C, alright? Okay, now step number 5, you have the multiplication sign, alright? You have the multiplication sign, so which means since it's a binary operator, I need to pop 2 operands. So C is the first one to be popped. You have C here, and then you have 5 here. So with each pop, what happens? The top value gets decremented, right? Okay, so the stack is empty. C will be popped. The value will change. The top value will change to 0, and then the moment 5 is popped, the top variable will change to none, remember? So in other words, the stack is empty, alright? So the value of C being 4, the result of 5 into 4 will be evaluated, this will be 20, alright? So the 20 as a result will be pushed back onto the stack, and then you will have the arrow pointing to 20, alright? And then I'm running out of space. Now let's say step number 6. Alright? Step number 6, you already have 20 here. Now the next up is I have the I'm done with the multiplication sign, right? I now have the D. So the D will be pushed onto the stack. Since this is the operand, and then you have the arrow pointing to the D. Step number 7. Step number 7, again you have this 20 and then you have here 7, alright? Sorry, you have D. What's wrong with me? Okay, you have D20, and then the final symbol is the division operator, alright? So again, since the division operator is very much binary operator, 2 operands need to be popped off the stack. So which means D will be right here, okay? D will be popped, and then up next is you have 20, which again gets popped off. You have 20 here. So the value of 20 is how much? The value of D is how much? It is 5, right? So 20 divided by 5 is 4. So this 4 will be pushed back to the stack, okay? And then finally, when the whole process is over, 5 will be popped off, which will be the result of this postfix expression, right? So this is how to evaluate the postfix expression. But it's not us. It's not for us. It's not us, who does this. We're just trying to understand how machine actually converts the expression which we are familiar with. We understand the infix, okay? So the infix expression is converted to postfix using the stack program, and then the postfix, is finally evaluated in order to come up with a concrete result again with the help of the stack, the technique, right? So basically, one important or the major important application of the stack is polish string, meaning in order to convert the infix to postfix, in order to evaluate the postfix, to come up with a concrete result, the technique of stack is used. Alright, so in order to make the matter even clearer, we'll take the first question and then followed by the third one. Right, so we'll just get rid of this. The reason why I'm coming up with this particular question is this is little different. This time we don't have the arithmetic operators like the plus, minus, multiplication and the division. Now this time we have the logical operators. There are three logical operators. The first one is and then you have the or, and then you have the not. So these are the three logical operators. And the operands, this time are not variables. Rather, they are Boolean values like true, false, true. Okay, so you have the logical operator with the Boolean values, right? So the logical operator should always go together with the Boolean values. So again, let's look at the first one. The method or the technique is exactly the same as the question number 2. So again, we'll come up with the first stack. Okay, so this is the first one. Since now these are the operands, true and false are the operands, not and or are the operators. So again, as per the rule, if it's operand, push it onto the stack. If it's operator, pop, evaluate the result and then push it back onto the stack. Okay, so the first one is true. True will be pushed onto the stack. That's step number 1. Step number 2 is you have true and then again you have false. So false is again an operand. Now this time the pointer or the arrow will be pointing to the false. And then step number 3 is you have true and then you have false and then you have true, right? So the arrow will now point to the topmost element, which is true. Now the next up is you have the operator. So what happens here is you have true here, okay, and then you have false. Alright, so initially you find this true. Now since you have this not operator, what happens is not is a unary operator. Not is very much a unary operator, which means it just needs only one operand to be operated. Hence, only one operand, only the topmost element will be popped. So this true will be popped. Alright, will be popped, and then you will have this operator of not. So not of true is false. Okay, so true will be popped, and then together with the operator, the result will be evaluated. Not of true is false, and the false will be pushed back to the stack. So you will now have false like this. Okay, so the result of this is false. Okay, I hope you're clear with step number 4. Okay, and then step number 5, and then again you will have the first one is true, and then you have false, and then now the next up is you have false here. So again, I'll have false pushed onto the stack. You have the arrow up here, and then number 6 again will be you have. Okay, now the next up is you have true here, right? So true, false, false, you have false, and then this is the latest entry, right? So this is the latest symbol. So again, you will have here true, and the arrow will be pointing on to the true. So I'm done with the Boolean value of true. Now the step number 7 is, I'll just copy this real quick. So you have true, false, and then false. Alright. Now since the next operator is OR, what happens here is these two elements will be popped off the stack. Okay, this is the first one that will get off the stack. Okay, so you will have true here, and then this will be the next. So you have here false. Okay, false or true means the result will be true. I hope you know this, right? So whenever you have OR, false or true means if one of the Boolean values is true, using the OR operation, the overall result will be true. It's like this. I want to see Tenzin or Sering. If I see Tenzin, my wish is fulfilled. If I say like Tenzin and Sering, unless and until both turn up, my wish remains unfulfilled, right? So likewise, false or true means the result will be true. So the result of true will be pushed back onto the stack, and the arrow will be pointing to true. Now the next up is you have the not. Okay, you have the not here, and then maybe I'll write here. Number 8. Not means again you have something like this, and then you have true. Okay, and then you have false. You have false. So now the next is the not. Alright, so this true, will be popped off the stack. Since it's a unary operator, this true will be popped off the stack. Not of true means the answer will be false. Okay, so the false will be pushed back to the stack like this. Alright, so since the next operator is not, the first and the topmost element will be popped. Not will be evaluated, the result of false will be pushed back to the stack. Alright, so I'm done with the not, and then now the next up is you have step number 9. Okay, step number 9 will be you have the AND operator. Right, you have the AND operator. So this time you have true, you have false, and then these two Boolean values will be popped off the stack, and then using the AND operator of false and false will obviously be false. Okay, so this value will be pushed back to the stack. Alright, understood? And then now you have this OR. Okay, you have the OR here. You have the OR here. So step number 10 will be, okay, you have true, and then you have false and false. Alright, now the next operator being OR, okay, next operator being OR, these two values, false and false, will be popped off, okay, will be popped, and then you will have something like this. False or false. Okay, false or false, the result will be false. And then this false will be pushed back to the stack. Okay, and then you have the arrow pointing to the false. And then finally, I'm sorry, it's a little messy, but it's pretty easy. And then finally, step number 11 is, okay, now the final operator is AND. Alright, so which means these two Boolean values will get off the stack, and then using the AND operation, false and true. Okay, false and true, and this will give us the result of false. Alright, and finally this is the value that will be pushed onto the stack. Okay, so once the logical expression is over, you will just have one Boolean value, and this is the result. Okay, so this is the result of this the postfix logical expression. All right. So it's very simple. So all in all, the crux of the matter is, if it's operand, keep pushing it onto the stack. The moment you have the operator, based on the nature of operator, pop the required number of operands. If it's unary, pop just one element, evaluate, and push the result back onto the stack. All right. So finally, we'll solve question number 3. So this should be a cakewalk. Okay, now let's say you have expression like this, 5, 6, 2 plus multiplication, you have 12, 4, division, and then you have minus. So these two questions were solved using a diagrammatic means. But at times in the exam, if you are asked to evaluate, don't be confused between the earlier table and this table. The question which was done with the table was converting infix to postfix. Now this tabular method is to evaluate or to solve the postfix expression. All right. So again, you will have the symbol here. Okay. And then why don't you have stack here? And this time maybe you could write intermediate. Intermediate means I would like to just use this, the slot for storing the temporary values, okay, which needs to again push, back to the stack, and the process has to continue further. So I'm just going to use this to store the temporary values, right? So it's quite simple. So the operator is 5. Or perhaps, just write the symbol here. Alright, and then I'll write here action. Okay. So the first symbol is 5. So the 5 needs to be pushed. This is again just another way to evaluate the postfix. And then on the stack, you would see 5. Alright. Now the next up is 6. 6 again has to be pushed. Alright. So I'll just this is 6. Alright. Just underline this to indicate that this is the topmost element. Alright. And then you have 2. Again, the action that has to be performed is the push. So you have 5 at the bottom, 6 on top, and then 2 as the topmost element. Right. So this underline is to signify that that particular number is the topmost element. And then you have plus. Okay. Now this plus, since it's an operator, I need to perform pop operation. Okay. I need to perform pop operation. Now the question is, how many operands need to be popped off? There should be 2. So the status of the stack will be just 5. Since 2 and 6 will be popped off the stack, and then using the intermediate, the slot for the evaluation, I now have 6 plus 2. Okay, 2 will get off first, and then followed by 6, and then in between you have the addition, the plus operator. The result will be 8, right? Now the next one is, you have the push operation. Push operation, this result of 8 will be pushed back to the stack. So one by one, the machine carries out the evaluation of the postfix. So this time it will look something like this. A will be pushed back to the stack. Alright? And then the next one is, you have the multiplication. Alright? You have the multiplication sign. So this multiplication sign, with this multiplication sign again, I need to pop. Pop how many elements? 2 elements. So I just have only 2 elements in the stack, which means the stack will be empty. Alright, stack becomes empty. The reason is you will have 5 multiplied by 8 is 40. Okay, so this will be the status of the stack. Since I have this multiplication operator, 2 symbols will be popped off the stack, and then the next step is, the push. Okay, push what? Push the result of 40 back to the stack. Alright? Okay, and then now you have this 12. Alright? It's 12. So 12 understandably will be pushed onto the stack. So the new look of the status of the stack will be 40 and 12. Alright? Okay, and then you have 4. 4 again needs to be pushed onto the stack. As a result, the stack will look something like this. And then you have the division operator. Okay, so this division operator means I'll have to pop how many elements? 2 elements. Okay, so 12 and 4 will be popped off, as a result of which you will have only 40 residing in the stack. And then 12 divided by 4 is equal to 3. Next up is push. Okay, so we are acting like the machine. So this is how the machine carries out the evaluation using the technique of the stack, the logic of which we have done in the earlier week's video lesson. Push the result back onto the stack. So you will have 40 followed by 3, and 3 being the topmost element, right? And then finally, what do I have? I have the subtraction operator. So subtraction operator, again, I'll have to pop 2 elements, as a result of which the stack will be empty. 3 will be subtracted from 40. The result of 37 will be pushed back onto the stack. Okay? So once the scanning of the symbols of the expression ends, whatever is left in the stack is the result of this particular postfix expression. Alright? So with this, I would like to wind up today's session. So we'll just try to quickly recall what we have done today. The first thing is, we have learned how to convert infix to postfix. There are 2 methods. The first one is the manual method, in which we have to start placing the brackets, okay, pair of braces according to the evaluation order, which starts with the bracket, okay, and then followed by exponentiation, multiplication and division, and then addition and subtraction, right? If the placing of pair of brackets become really complicated, I advise you to mark the first operation maybe through an underline. This will help you to minimize the number of brackets. If you put too many brackets, if you miss out on one accidentally, you could mess up the whole thing. So I think it's better if you could underline or highlight the first operation to be evaluated, and once that's over, and then again look at the new order, and then again mark the next one, evaluate that, and then go so on and so forth. Okay? And then the second conversion technique is using the very stack technique. Okay, and then you have this algorithm or the rules. There were like 4 or 5 steps. Okay, I don't think I have to recall again. I'll be giving you the notes. So that's the second method of converting the infix to postfix. And then we have learned how to actually evaluate the postfix. Evaluate the postfix means it's now time for the machine to process the expression for the final result or the final value. Okay, so again, even though I've shown you 2 ways, but logically, technically it's just the same thing. the way I have presented the answer is a little different. So in the exam, if you're asked to evaluate the postfix expression, you say the diagrammatic means, why don't you go for this? Okay, if you're asked to do it through tabular format, then you'll have to do this. Okay, otherwise, the logic of these two, the techniques are exactly the same, right? So with this, we have come to the end of today's video lesson, and then next week, I'll be touching upon the last final segment of the all-important chapter of the data structures, and that's going to be the cues. Okay, so I request everybody to stay in touch with the latest the video, and then try to get hands-on practice on the system. That's really very important. And then what is even more important is try to grab it totally. Okay, so please study hard and take care. Thank you very much.